Hey everyone, my name is Puru Arora and I welcome you all to this channel. Today we are looking at the problem maximum length of repeated subarray. It is a medium level problem on Leetcode and it is not very easy but it's not very tough either. So let's look at the problem. Given two integer arrays number 1 and number 2, return the maximum length of a subarray that appears in both arrays. That means we are given two different arrays. We need to find the highest length of a common subsequence in both these arrays. Longest, not highest. So let's see the example. Here we have number 1 equal to 1, 2, 3, 2, 1. And here we have 3, 2, 1, 4, 7. So we can see that 3, 2, 1. This is a common substring that is occurring in both these arrays and the length is 3. So we just need to simply do that. Now the very first approach that comes to our mind is using triple loops. So that is how we'll initiate a first loop for the number 1 array, then we initiate another loop for the number 2 array, and then we check if the ith element of the number 1 array is equal to the jth element of the number 2 array. If that is the case, then again we initiate a loop to check for further ahead if how many further elements are let's say equal. So this is a process that will definitely work, but it will take n cube time. Also, if you observe a little bit carefully over here, we'll see, like, suppose for a number, let's see in this example, suppose for 3, we'll again go for 3 be the ith element of number 1, and now we'll start at 0 element of that is j. So 3, 2, 1, 4, 7. So it will compare and give us the length 3. But now again we'll compare for 2, then again we'll see the length is 2, and we'll notice that this part is being repeated. So this way we can deduce that this question is based on DP, that is dynamic programming. So we need to insert some sort of memorization logic in this question. The very first approach that we talked about using triple loops. Out of those 3 loops, 2 loops are very necessary because we need to iterate over each and every element. So let's write that code. So till now I have initiated a variable. That will store the maximum length in my case, and also I have created these 2 loops for iterating over each element and comparing it with the element of the outer array, in this case number 1. So now we need to insert some kind of logic here that we can know what was the value of the previous element, what was the value of the substring till the previous element. We need to insert some sort of logic. So in this case we can use a 2D matrix. So I'll show you how. So now I have created an array 2D matrix with this length plus 1. So why am I using this length plus 1 is because I'll be including the values for the last element too. So we'll be calculating for the last element, for the second last element, and so on. So we'll have a result, we'll have a value that will be calculated after going over the last value. So we need somewhere to store that value too. So now if the element at the current ith position of the number 1 array is equal to the element at the jth position, Then what? Now the element at ith and jth is equal. Now we need to store the size of the array we have, store the size of the largest subarray. So now we need to use some sort of memorization technique. That means we will use what we already know. So in this case, the matrix that we created will use that. So let's say, so now you can see we have a matrix over here, and when we iterate over the loop, you'll see like we have some kind of pattern emerging over here. And even if you look more carefully, you can see the current position is being influenced by the previous diagonal element. So that is the thing that we are going to implement over here. So dp I plus 1 j plus 1 is equal to 1 plus dp. Now as you saw in the matrix, we were going diagonally downwards. So why I'm doing 1 plus? Because we are moving one step ahead. So that is why I'm storing the value of these elements, the value of the ith and jth element in this matrix. Now I'll just initiate my max to the maximum value what we have over here. I think we are done. Yeah, let's run this code. Yeah. So this was my approach for this problem. The obvious approach that you can use of n cube, that is also a fairly nice approach, but this approach reduces your time complexity. That approach will take n raised to power 3, but this will take n raised to power 2. So it drastically decreases your time. So I'll see you guys in the next one.